Today, I'm going to show you how to create a phylogenetic tree using FASTA files of a specific gene of several species. In this manual, I used both the COX-1 gene and the GAPDH gene to create phylogenetic trees. So the first step to do this is to obtain your FASTA files. I used NCBI to obtain my FASTA files using the nucleotide database. And it's fairly simple to do this. You just search for the species that you are looking for. So if we're looking for humans, we just put in Homo sapiens and then search GAPDH. Here we search that. And we can click on the gene information for humans. And if you scroll down, there is a FASTA link that opens up a FASTA file here, which we can download right here. And you can download the complete record and file in the FASTA format and create file, and it will go to your downloads. Now, after you've obtained the data, I created folders for the two genes here, and I collected data of 8 species for each gene, and I put them into these folders. Now, once we've collected the data that we're looking for, the next step is to align that data. So you have the genetic sequence of each of these different species genes, but now you want to have that information all aligned so that we can use the APE package in R to create the phylogenetic trees. So to align the files, we're going to use a tool on Galaxy called Clustal W. Search here. And this tool uses the FASTA files to create a Clustal file, which is aligned. Now, first, when using this tool, you have to upload all of the FASTA files for a specific gene that you want aligned in one file. Now, using NCBI, we got each of our FASTA files as separate files. Now, if we put all of our data into one folder, as I did here, we can easily create a combined file using terminal. In our terminal on Mac, there's an app which is just called Terminal, and you can use command line to create the file, the combined file that we want to make. So here, if you navigate to the specific directory that we want to use, which I used the COX-1 sequences directory. You can use the ls function to list out all the files that you have here. And this shows the 8 species cox1.fasta files that I have. And then using the cat *fasta command, we can combine all of these files into one file and put them into a new file called allcox1.fasta. In doing so, creates this file here, which we can use the Clustal W tool on Galaxy to create an alignment. So once we've done that, we can go to Galaxy, go to the ClustalW tool, and you can upload the data from your computer here. And once you have that data uploaded, you can select it here. So this is the Cox1 FASTA, and then you can just run the tool, and it will create two outputs. And the Clustal output is the one that we will be interested in. Now we just wait for this to finish, and we can use that file. Now that that is finished, we can look at the Clustal file, and we can see the alignment of each of the 8 species. And a star here indicates places where every sequence has the same base pair. Dashes are gaps in the sequence. So now that we have our aligned file, we still have one more step before we can create the phylogenetic trees in R. So we have to convert this from the Clustal format to back to the FASTA format. So to do this, we can download the file right here. And then once you have the file downloaded, you can simply just Google Clustal FASTA. This is the tool I used, just the website where you select from Clustal to FASTA, and then you choose your file, and that will convert your file that you obtained from Galaxy from Clustal to FASTA. And once you have your FASTA file, right here, the aligned FASTA file, now we can create the phylogenetic tree. So to do this, I'm in RStudio, and we will need the APE package. So if you don't have it, you can just type install.packages ape and then run the library. Now, to load in, to create a variable of our FASTA file, we use the read.dna command and use format equals FASTA after the pathway of the file. And this creates a variable. Next, we want to make a distance matrix of our file, which I called sequences here, our FASTA file. And this basically quantifies the distance between each of the sequences. There's our distance matrix. And now we use the command nj to create a neighbor joining tree. Nj stands for neighbor joining tree. This type of phylogenetic tree. We run that, and now we can plot out the tree. And this creates a phylogenetic tree right here. Now this is using the accession numbers of the file, which if we look at our aligned FASTA file, we can see that these are the accession numbers that the program is using to make the labels for each branch. Now, if we want to use the species names rather than the accession numbers for each of the branches, we can copy this file and replace the names, replace the accession numbers with the species names. And if we do that, we can create another phylogenetic tree by rereading in this file with the new names, not the accession numbers, but the species names. We run that, create the distance matrix again, create the neighbor joining tree again, and then plot it. See, we get the exact same relationship, the exact same tree, but now each of the accession numbers are replaced instead with the actual species names. And that is the COX1 tree. And here I did the same thing for the GAPDH gene. And if we run all of that and plot it out, here we get a tree based on the GAPDH tree. So now I have two trees here, two evolutionary trees, one based off of the COX1 gene and one based off of the GAPDH gene. And that is how you can use APE to create the phylogenetic trees using FASTA files obtained through NCBI. Thank you for watching.